With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, we need to find that using Einstein photoelectric equation, show that how the cutoff voltage and the threshold frequency for a given photo material can be determined with the help of a suitable plot or a graph. Now, first of all, we just write something about our this Einstein photoelectric equation. So, for example, if this is the incident photon, okay, which is basically which falls on a metallic surface. So what will happen? So there would be electrons on the surface itself. Okay. Now this photon, okay, which is just this is the energy of the photon which we have represented. So it would be interacting with the electron. Now if the energy is sufficient, then what will happen? Then ejection would take place and electron would be coming out of the surface. Now if the energy, so basically we can say that this h nu of the energy would be going to make the electron to come out of the metallic surface. So we can say that this would be its work function. And if there is some amount of energy which is left, so that energy would be provided as the kinetic energy to the electron. So we say that it would be the kinetic energy which would be provided to the electron. Okay. Now what is the work function? So work function is the minimum energy which is given to a photon so that the ejection takes place, and it is represented in terms of, we just write this expression once more, it is represented as to be in terms of nu naught, where nu naught is the threshold frequency, and this is the maximum kinetic energy of the electron. Okay. Now to get the value of the maximum kinetic energy of the electron, okay, how do we measure? We measure it with the help of the cutoff voltage, and it turns out to be E into Vs, where Vs is the cutoff voltage, nu is the frequency, Vs is the cutoff voltage, and nu naught is the threshold frequency. Now from this expression, what we can say that our Vs or the stopping potential would turn out to be H divided by E nu minus H divided by E into nu naught. So we have just taken to the other side and divided the expression by E. Now if we just plot this expression, so what we will be getting? Now if we just plot this expression, so let's say this is our vertical axis, this is our horizontal axis, and here we are taking the frequency, here we are taking the stopping potential. Now what is this line? This is basically a straight line. Okay, this would be a straight line. Why? Because this is a linear equation in terms of frequency, because here we can see that it is a single power of nu and it's single power of v. So this would be a straight line. Now if we just plot our straight line, so it would be something like this. Okay. Now what is this value? This value, at this value we can see from the graph at this value Vs is equals to 0. So if we put the value of Vs to be equals to 0 into this expression, what we will be getting? We will be getting nu would be equals to nu naught, or we can say that our frequency would be equals to this threshold frequency. Okay. So from this graph, if we are given this graph, we can directly say that from the this stopping potential and frequency graph, the point at which this graph cuts the frequency axis would be our threshold frequency. Threshold frequency. Okay. Now this would be the value. And what is the slope? So we can clearly see that our slope, if this is our theta, so our tan theta would be the slope, and it would be h divided by e. H divided by e. So this would be the case. Now below this, we can see that our stopping potential would become negative, or we can say that our kinetic energy would become negative, which is not possible. So generally we just used to draw with the dotted line. Okay. Now this is one of the case. Now to get the value of the stopping potential, how can we get the value of the stopping potential? So if we just know the frequency, okay, so from the graph we can just plot. For example, if at some point we get to know what is the value of the frequency. Now from this graph we can, if we just read into this expression from on the left side, on the vertical axis, we can get what is the stopping potential. Okay, we can get the value of the stopping potential. That means stopping potential is dependent upon the frequency. Now there is another graph which is already also represented in terms of the stopping potential. So this is one of the graph, and the another graph which we just draw. So for example, this is our vertical axis, this is our horizontal axis. Now in the horizontal axis we plot the potential, and on the vertical axis we just plot our current. So we have seen that this current versus this potential comes out to be like this. So there would be a saturation value, there would be corresponding to any frequency. Let's say the frequency is nu, so there would be a saturation current. Now if we just increase the reverse potential, okay, just to stop the electron, if we just increase the reverse potential, we just draw a curve like this. So this is like this. So there would be a point at which our current would turn out to be 0. There would be a point. So from I we are not representing the intensity, but we are representing current. Now at one point our current would become zero. That means what? That means that our electron has lost the kinetic energy. Now the kinetic energy is basically a function of what? Maximum kinetic energy. It would be equals to E times the stopping potential. Now if the current is zero, that means kinetic energy is zero. So kinetic energy would zero would correspond to the voltage. Okay, so we can just measure the voltage at which our kinetic energy is, or we can say that our current is reducing to zero. Okay, so this would be the value of our stopping potential. So from I and this voltage graph, we can get the value of the stopping potential, and from here also we can get the value of the stopping potential corresponding to any frequency. So hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.